let's go ahead and take a look at a full example of performing a hypothesis test for a mean. Again, we follow the same steps. We have our sample data. What we're trying to test to see, is there evidence that the true mean runtime for all participants is below 30 minutes. So you can see that turns out to be the alternative hypothesis. The null is mu equals 30. We're going to run a one sample t-test. Notice there's no stated alpha or significance. So if there isn't, you choose one, and most of the time you choose an alpha equals 0.05 or 5% in a social science setting. 5% is our alpha. We have to check the requirements. Is it independent, the samples? Less than, I think 20 would be less than 5% of all runners. Is it random? Is it a random sample? We don't know 100%. I'm not sure. I'm not clear. So anytime we're not sure that we're meeting the requirements, we can still do the calculations. We just got to be careful with our interpretation. And the same thing, is our data large enough? 20 is less than 30, so it's not necessarily large enough, but we'll still do the data. But you want to be aware that we could have some potential issues with our interpretation, but we're going to still do the calculations. We can still do the hypothesis test. We're going to calculate the test statistic using the sample data, right? There was the sample data in green over here. That goes into it, and then you get your test statistic. After you have your test statistic, you go ahead and calculate the probability that that was less than, right? Because we're using a one-sided left tail test. One-sided and left tail test here. And you end up with, and again, one-sided left tail. Again, we're calculating the probability, and this t distribution, we're calculating the probability, right, that it is less than over here with this t equals negative 0.631. That's what we're looking at here. Once you get your p-value, then we compare that to the alpha. And remember in the notes, the lower the p-value, right, the likelihood that we would reject the null hypothesis. But since this p-value is greater than alpha, we fail to reject the null hypothesis, which then means there's not sufficient evidence, or there's not sufficient evidence to conclude or support that the mean runtimes was actually below 30. And so what we're saying is we're accepting that and we're rejecting that, right? Do not reject the null hypothesis, which means we're accepting that and rejecting that. Okay, let's go look at another example. This time the data is given to us, and an insurance company wants to know the life expectancy of, or last year the life expectancy of their policyholders was 77 years old, right? And so what they want to do is insurance company want to change the premium if there is evidence that people who buy policies are living longer. And so they collect some data, and so what they're thinking about is they're looking at if the mu is 77 or if it's greater than 77. Remember, because if it's greater than 77, then their policyholders are living longer, and maybe they have to update their fees, right? And so the data is here, and what you have to do in this case, since we're given data, you would put it into StatCrunch. Sorry about that. I have it here. There it is. You'd put the data into StatCrunch after you open it up, okay? Or if you are in the art of stat, you're going to go to inference for a population mean. You would have your own, and then you enter the data in. Okay, so you got to go to the art of stat and do that. And then what we're going to do is we can run actually a significance test here too, calculate it when we have the data like this. We're going to run not a confidence interval, but significance test. The null hypothesis was 77, and this was a greater than, right? We're going to run the greater than one. And so then you can see you get your test statistic here. You get your mean and standard deviation. And so you get that data there. Same thing on the StatCrunch. You would go to t-stats. And again, this is also in the notes, some of these instructions. One sample with the data. And so it's in the age. We're running a hypothesis test. 77 was the value, and it was greater than 77, the alternative. And then just hit compute. And then you end up with those values also, the test statistic and then the p-value. Okay, and so that's where I got those numbers. Another way to think about that data there. And so let's go ahead and take a look at what we have here. So that's where these numbers come from. After you have your sample data, you can go ahead and recalculate this here, you see 1.598. Its p-value was 0.063, the one that we got, right? And so once you have that p-value, then we go ahead and make a decision. Since the p-value is greater than alpha, and again, we weren't given an alpha on this one either, so when there is no alpha given, we're going to assume it's 0.05 when it's not given to us. And then since the p-value is greater, we fail to reject the null hypothesis, which again means there's insufficient evidence to conclude that the life expectancy is greater than 77. We're not rejecting it, so we accept it, and we're saying that's not true. And so now I know. And remember, when we make our conclusions, it's always with respect. When we make these statements, it's with respect to the null hypothesis.